All right, AP Stats. So another series, videos, always. So here we go. We're now again looking at quantitative data. Now we're going to look at working at and describing that set of data. Did last section 1.2, doing it with graphs. This section, doing it with numbers. So this video is going to focus on measurements of center and spread. The other videos will then look at quartiles, outliers, how do I determine outliers, and then also how do we go about describing quantitative data. So we already kind of did that a little bit in 1.2, but sort of informally. This section we're going to get into that specifically using the numbers as well as what we see in graphs. So let's jump over to the whiteboard and talk about how to do actual calculation. Okay. So on our whiteboard, and what we're going to do is we're going to talk about measures of center spread. So this is going to be a little bit of an algebra view because we're kind of should be familiar with some of these already. So with measures of center, there were three types that we remember from algebra, but we're really going to in AP Stats concentrate on two of those three. So center. So mean, there was a median, and then there was. So we're going to concentrate really on these two here. Mode really was just the number that appeared the most. And now sometimes there might be more than one mode. So we want to kind of be a little bit more definitive in what we are talking as a center. So we're going to really focus on the mean. So the mean, if you remember, was just summing up all of the data points, and then you divide by the number of data points. So that was the mean. Shorthand. So we add up all the data points, divide. So it was a calculative way of finding the middle. The median was literally the middle number. So we had to arrange the data set in order and then find the middle. Whatever that middle number was, that became the mean. If it was an even data set, then we would have to take average of the two middle numbers. So remember kind of doing that algebra had like 10 data points. What's the middle? Two middle numbers were 5 and 6. Would say that the median was 5.5 average. Now, the reason why we're going to look at these two in particular is because sometimes it's preferable to use the mean. Other times, it's preferable to use the median. So, and I had said this example earlier in the course already, was when we looked at annual income of a neighborhood. So if I, take a poll or I go around, I do a questionnaire of what's the annual income, and let's say on this end of the scale we have anywhere 50K. And then some new guy comes to the neighborhood, he's retired, he's over here on this end of the spectrum, 1 million. So if I were to ask for the mean, if you were to average this by summing up all the values and dividing by the total number, the mean would be somewhere here. While the median, even with the addition of a point like this, would still be somewhere kind of here. That would be the middle number. So if I ask what is a better measure of center, where's the center of the data, the median would better describe the group as a whole versus the mean, which is really not describing anybody. Now, vice versa, it could happen the other way. What if we have, a high end neighborhood everybody's like 500,000 or $1 million, then moves in a family that annual income is below the poverty line, that would also cause the same kind of effect. The mean would not be particularly measure. The median, however, would be a better measure of center. Now, if this person did not exist, so if we did not have Bill Gates, then the mean and the median would be pretty much in the same position. Might be a little bit higher, might be a little bit lower. You would have to have more specifics, but the mean would be somewhere also here. So when that happens, when your mean and median are kind of agreeing with one another, they're around the same ballpark, that's usually a good indicator that you don't have um, many outliers, or the data is spread out symmetrically. So even if there were outliers, probably just as many outliers here on this end. So the mean and median are kind of balanced. Okay. When the mean is greater than the median, like it was here, you saw I had an outlier sticking out here. That influences the mean to being greater than the median. If the mean was less than the median, then that indicates to me that there's an influencer on the low end, just dragging. So again, causing that skewness in our graph. So that's what that indicate. Looking is that center. All right, now let's talk about measures of spread. So spread. So for right now, we're going to talk about main one. So it's not just important to find out where the middle is. I also want to know, how does the data vary in this pool of information? Are all the points really close together? In a case of our incomes, is everybody kind of earning the same amount because we all kind of work for the same company, or is there varying amounts and it just, the middle happens to be some number that really doesn't kind of hug tightly with everybody's so how does the data spread? So a very basic way of measuring spread would be range. So remember how we calculate range? It is the highest score versus the lowest score. So highest versus lowest. We do that little subtraction, and that tells us, well, this is how wide the data. That was a very basic way of measuring range. Then there is what we are going to look at, P-calc, which is the IQR, or interquartile range. So IQR is the interquartile range. So instead of subtracting the highest value from the lowest value in the set, we're going to subtract the third quartile from the first quartile. So quartile, if you've never heard of that term before, and that's fine if you may have heard of it, the same as percentile. You might be more familiar with that term because if you've taken an SAT or an ACT, you usually are given what percentile you are in. So if I am told I am in the 95th percentile, that means that my score is higher than 95% of the population. My score is 95% higher than the population. That's what percentile means. Quartile, quarter. So we're going to take our percent, our population, and divvy it up into quarters. So what we're going to do is we're going to take the third quarter, 75th percentile, whatever that value is, subtract it from the first quartile, which would be the 5th percentile. So when I do this interquartile range, so imagine this is the entire population, divvied it up into quarters. When you do Q3 minus Q1, you're getting is this middle 50%. So typically, if all of our data, the middle 50%, is, usually the interest. It's where we typically will see the mass of data. So I'm probably more interested in looking at that, and that be a better indicator of spread than if I looked across the entire population. Okay. Because if I told you, well, the range for annual income in the United States is 2 billion, that's a huge range. Why is it so large? Well, there's the lowest income, which is I have no job, I have nothing coming in, versus the highest income. Here comes Jeff Bezos, and they're earning billions of dollars a year. That's a huge range. But does it really vary that much? Well, let's look at the middle 50% of the population. So by doing an interquartile range, we kind of get a more we get a clearer picture of, okay, well, the middle income people, are they really as largely varied as the highest and the lowest? Or is there, does that indicate again that those two are really extremes? Not a lot of people are in those extremes. Middle, how do they vary? Because that can happen. We could have quite a bit of data that is masked in the middle. And then, yes, we're going to have those outliers at either end. But if I measure that range, it makes it sound like everybody's spread out across the spectrum. When really, most of the people, that middle 50, spread across a small uh, window. And that could help us. And again, thinking about applications of measures of spread and center, that can help influence how we develop policies, economic policies, for example. Like, okay, if I'm in government and tax breaks, incentives, I want to affect as many people as possible. So, should I give a tax break to middle income? Well, are they widely varied? Because if I come up with a specific targeted policy, okay, well, if they earn $50,000 a year, give them a tax break. Is that really going to help a lot of people? If I go across bigger one, the range, if I use the range there and think everybody's spread equally along the spectrum, then I might be giving tax breaks that might only affect a small portion of the population, not have the intended effect that I thought it was going to have, because I was just kind of going off of that one number. So, guiding principle in stats is not one number is going to tell you the. So, like with measures of center, just because I get the mean does not tell me the whole picture. The mean and the median together start to clear up a picture. If they're the same number, okay, start to kind of get this picture of what this distribution might look like. Median and the median are the same. So, okay, might be symmetrical. Maybe it's a bell curve, but at least I know it's symmetrical. There's just as much on one end as there is on the other end. And the median are at the same number. But if they weren't, then that's an indication to me of like, okay, data is skewed. Depends on how the mean and the median to one another spread. Is it a tightly hugged bell curve like this, or is it more of a flatter curve like that? That's what the range will tell me, interquartile range. So any one number is not going to be the end all be all definer of what is happening with our distribution. It's going to be all of these numbers in concert carving out this picture for what the distribution looks like without us having to get into the actual raw data. Stats is summarizing that raw data into smaller numbers for us to be able to make summary judgment.